Hey y'all, we are starting the last section of chapter 9 today. There's two parts to it. We're just going to do the first part today, which hopefully will be pretty quick and easy. Today we are talking about how we classify a conic section. How do we determine if it's a parabola, an ellipse, a circle, or a hyperbola? We have this lovely chart here, and I will tell you honestly that I don't ever pay one bit of attention to this chart. I don't memorize it. I don't think I've ever really even seen it until I started teaching. I just don't pay attention to it. I'm going to tell you how I go about doing this, and if you think it's easier to memorize the chart, then by all means, you memorize the chart, but I'm just not even really going to talk about it. So we have equations. And in all of these sections, we have been asked to write them in standard form. So a couple things I know, okay? The parabola is the only one that has only one variable that's squared. So either the x is squared or the y is squared. So if I'm looking at an equation and both of my variables are squared, I already know it's not a parabola. If I'm looking at my equation and only one of them is squared, then I know that it is a parabola because there's no other choice if only one variable is squared. So right away, I can tell quickly, is it going to be a parabola? Now, if we look at example number 1, I can already tell you that it is not a parabola because I have the x squared and I have the y squared. So I already have one of those shapes out of the way. Now, the other thing that I notice is that the variables are on different sides. And so right away that tells me I need to get the variables all on the same side. So I think what I'm going to do is get these y's and move them over to the other side. So here's what I have. I have 4x squared plus 8x. Now remember, I'm taking these two things and I'm moving them over. How am I moving them over? I'm subtracting them over. So I've got minus y squared minus 6y equals 13. All right, so all I've done so far is I've moved so that all of the variables are on the same side. Now you know with all of these we've been completing the square, and you remember the rule for completing the square. Your leading coefficient has to be a 1. So that needs to be what I'm focused on next. So I'm looking at the x's, and I notice that the leading coefficient is not a 1, it's a 4, which means I have to take it out. So when I take it out, I have x squared plus 2x. Notice I left some space because remember in a minute we're going to complete the square. Now as we look at the y's, my leading coefficient is also not right because I need it to be a 1, and what I see is a negative 1. So I have to take the negative out because in order to complete the square, I need to be a positive 1 for my leading coefficient. Well, when I take it out, my negative y squared becomes a positive y squared. Not only that, but the negative 6y turns into a positive 6y. Hopefully everybody's following me on this so far. So I took out a 4, I took out a negative 1. Now look at what you have so far. We're about to complete the square, but here's something that's important. That minus sign. There's only one choice left that's going to have the minus sign in between the variables. Do you guys remember what that is? We'll keep going and see if you do. So let's go ahead and start with completing the square. So I'm going to take half of b. So half of 2 is 1, and then I'm going to square that, and 1 squared is 1. But when you go to put that value on the other side, you have to keep it balanced. So if you were to distribute the 4 to the 1, that really represents a value of 4. Same thing here. I'm going to find half of b. So half of 6 is 3, and I'm going to square that, and I'm going to get 9. But again, I have to ask myself, if I distributed the negative sign, the minus sign, the negative 1 to that, what would it really be? And it would really represent a negative 9. So you have to keep your sides balanced. All right, so over here, we're going to take that perfect square trinomial that we've just created, and we're going to factor it. So it turns into x plus 1 squared. we're going to take the perfect square trinomial that we created for the y's, and it's going to turn into y plus 3 squared. And on the right-hand side, we're going to combine like terms. So 13 plus 4 is 17, and 17 minus 9 is 8. Now I need that 8 to be a 1. So I'm going to go through and divide everything by 8. So in the first fraction, that reduces. 4 over 8 turns into 1 over 2. In the second fraction, there's nothing to reduce. So that stays as is. And on the other side, we now have a 1. All right, so did y'all think about it? Did you think about which is the only one to have a minus sign? Only the hyperbola. So this is a hyperbola. So we've classified it, and we have written it in standard form. All right, example 2. Right away, I notice that I have an x squared, but I do not have a y squared. So this already tells me this is a parabola. When you only have one variable that's squared, it is going to be a parabola. Now what I also know is that the x's and the y's need to be on different sides for the parabola. It's the only one where you're going to put them on different sides, and they already are on different sides. So I have 6x squared plus 12x equals negative 3y minus 9. I'm just rewriting it. Now, again, all of these require completing the square, which I can't do yet because I have a 6 here and I need my leading coefficient to be a 1. So I'm going to take that 6 out. So I'm going to have x squared plus 2x. Again, you see that I've left some space. On the other side, I have negative 3y minus 9. Haven't done anything to it. So let's complete the square. Half of b, so half of 2 is 1. Square the 1 and you get a 1. But really, what is its value when the 6 distributes to it? It's really a positive 6. So again, you got to keep both sides balanced. Every time you complete the square, whatever you add to one side is the same value you should be adding to the other side. So we get 6 on 2. We're now going to take that perfect square trinomial that we created and write it as x plus 1 squared. On the other side, I'm going to combine like terms. So I have negative 3y minus 3. Now, if you remember from when we worked with the parabolas in this chapter, we typically, our goal next is to solve for y. But before we try to get y by itself, on the other side, I could take what out. If I wanted this to be a 1y, what would need to come out? I would need to take out a negative 3. So I'm taking out a negative 3. I'm using the distributive property backwards. I'm dividing by negative 3. Negative 3y divided by negative 3 leaves us with y. Negative 3 divided by negative 3 leaves us with a positive 1. Now what am I going to do with that number that I just took out? I'm going to divide it on over. So on the other side, 6 divided by negative 3 turns into negative 2. So I have negative 2 onto x plus 1 squared equals y plus 1. And then the last thing I'm going to do is get y by itself by subtracting 1 on each side. So I have negative 2 onto x plus 1 squared minus 1 equals y. So there is our standard form of the equation. We could tell early on that it was a parabola because it only had one variable squared. All right, last example in this section, and then we'll be done with part 1. So I've got x squareds, I have y squareds. That already eliminates the parabola, so I'm going to ignore that idea. The good news is that the x's and y's are already on the same side. So I have 9x squared plus 18x plus 4y squared plus 8y equals 23. Now you know we're going to have to complete the square. Again, that means our leading coefficient needs to be a 1. So for the x's, I'm going to take out a 9. So that's going to leave me with x squared plus 2x. Again, I've left some space for the constant. For the y's, I'm going to take out a 4. That's going to leave me with y squared plus 2y. Again, I'm leaving some space for the constant. And on the other side, I still have equals 23. All right, so half of b. Half of 2 is 1. 1 squared is 1. But what value is it really on the other side? It's really a 9. Same thing over here. Half of 2 is 1. 1 squared is 1. But what is its value really? It is a 4. So we have 9 onto x plus 1 squared plus 4 onto y plus 1 squared equals 23 plus 9 is 32, and 32 plus 4 is 36. All right, I want that 36 to be a 1. So I'm going to divide everything by 36. 9 over 36 reduces to 1/4. 4 over 36 reduces to 1/9. And 36 over 36 turns into a 1. Okay, so we already got rid of parabola, that it couldn't be a parabola. In the very first example, we had a hyperbola because there was a minus sign in between, but we don't have a minus sign, so that's going to leave us with an ellipse and a circle. Which one do you think it is? This one is going to be an ellipse. How do I know? Because my denominators are not the same. If they had both been the exact same number, then I would know that this is a circle, because that would have represented the r squared. But because they are different, that tells me it's an ellipse. All right, so just to reiterate, it's going to be a parabola if only one variable is squared. It's going to be a hyperbola if when you have the x's and y's on each side, on the same side, but you have a minus in between them. And when they're on the same side and you have a plus in between them, it's either an ellipse or a circle. The way that you'll know is depending on the denominator. If they share the same denominator, then it's a circle. If they have different denominators, then it is an ellipse. That's why an ellipse is kind of wonky shaped and it's longer one way than it is the other, because the denominators weren't the same. That's why a circle looks so perfect, because the denominators were the same. So whether you were going up, down, left, or right, you were going the same amount every single time, and that is called the radius. So your homework assignment is on Ren Web. There are only 4 problems like these, and then in the next video is where we will finish 9.6, and we are very close to being done with the chapter. And I will see you guys in the next video.